Hey there, this is Math 8, Unit 2, Lesson 3, talking about dilations with no grid. That means we're not going to have any grid paper like this today, and we're not going to have any circular grids either. It's just going to be free-flowing dots and rays all over the place. So let's take a look here. First of all, you are asked to find and label point C on the ray whose distance from A is twice the distance from B to A. So to do that, what you're talking about is saying whatever the measure of this element here, I can go ahead and I want to double that up on my copy. You could measure it if you chose to measure it, that is just fine. Or if you wanted to, you could just use a piece of paper, right? And you could just go like this and say, well, it's from here to here is that long. So there's my distance, and let's go to the edge of this paper here and mark it, and there I am at C. So that's double. 1, 2, there's point C is twice the distance from A. Okay, that's the first part. Then you have to find and label point D on the ray whose distance from A is half from A to B. So A to B is here. If you wanted to find out for sure, you'd measure it, but for now, just as for reviewing, half is about here, and so we would say D is my half point there. So then, from there, we went to what was called dilation obstacle course, and it says to look at these 9 points, and then we're going to use some scale factors to figure out different things. It says to first dilate B, so we're going to move B using a scale factor of 5 and A as the center. So there's our center point A, and we're going to dilate point B by a scale factor of 5. First thing I want to do is create a ray connecting A and B and whatever else might fall in its path. So I'm looking at that being the center. Think back to yesterday, right? If this was like my circular grid, right? That's the idea. That's a point there somewhere. And this happens to be wherever it happens to be. It doesn't really matter. And whatever that distance is, I want to make that a scale factor of 5 to find out which point is a scale factor of 5 away from that shape there. If I was to measure it, in this case here, I'm a little bit less than 1 inch. I'm looking over here at centimeters, I'm about 2. So let's use centimeters for now, because if this is 2 centimeters there, and I want to do scale factor of 5, 2 times 5 is going to give me 10 centimeters. And the question is what point is at about 10 centimeters? Here it is. It's point I. So we would say the point is point I for the scale factor of 5 dilating point B. Using H as a center, so using this as our center point, just I can draw a circle there for this one. That's center dilation. Dilate G so that its image E, so there's image E. What scale factor did you use? So going G to make the image E, and we're finding out what the scale factor is between those 2 points. Again, the first step is going to be to draw a ray from our center point through the points we have here. So I just draw my ray right there, and I take a look at G. So here's my G, starting there, this part here, and I can measure that if we chose to, and perhaps I notice with centimeters that it's 3 centimeters. So I'm starting at 3, so I have 3 centimeters times a scale factor of some sort is going to get me all the way to E. E happens to be at about, well, we could say it's 9, we could say it's about 9, hard to say exactly. Let's go with 9, it's pretty close there. So we're going to 9. So to find out what my scale factor would be, I divide both sides by 3 to get scale factor by itself. And the scale factor is 9 divided by 3, which is simply 3. For number 3, it says use H as a center. Dilate E, so that's image G, so it is image G. What scale factor did you use? So if we're going to go from here to there, we're going to go from 9 times the scale factor to get to 3. So this whole length is 9, correct? From there to there is 9, and we're going to go to 3. So that becomes, divide both sides by 9 this time, and we end up with a scale factor of 1/3, which makes sense because if this to go from small to larger was 3, and we're just going the opposite direction, it becomes the reciprocal, 3 1/3. For number 4, it says to dilate F so that its image B is image B. What point in the diagram can you use as a center? So we're moving this to point B. Okay, so let's just draw a little line and connect those together and see what happens to fall in the space between. And so we have this line here. So to move that to that, I need to be able to move it from there to there from a certain point. In this case, we'd be best to use point C as our center to say I'm going from there, from this place, down to this place. That becomes my scale factor, how I do that there. So we're going to go with point C. The next thing I ask you to do, which is on the next page, is it says dilate H, this is number 5 by the way, dilate H using A as the center and a scale factor of 1/3. Which point is its image? So we're going from H, we're taking this distance here, and we're going to multiply it by 1/3. So measuring it there, we're at 6, so we're distance from here to here is 6, times a dilation of 1/3, this is all for number 5, becomes 6/3, which becomes 2, and at point 2 we're at B, so we would say B, that's number 5. And finally number 6 says, or not finally, but more to go, 6 says describe the dilation that uses a labeled point at its center that would take F to H. So what would we be able to move F to H from? If we want to go from here to here, I need a center point that's not on that line but is connected to that line. We'd go with choice E, so point E. So number 6, we're going to go with point E, okay, to go from F to H. And if that's the case, which it seems to be, we're going from 3 to 3, 6, 9. So you're going from a distance of 3 to 9. So our scale factor just on the side is going to also be 3. That's our scale factor for number 6. And then number 7 asks, using B as a center dilation, dilate H so it's the image of itself. To be the image of itself, it has to stay where it's at. Okay, it can't move, which means your scale factor is simply 1 because nothing is moving and changing. So those are the questions that are on this page right here, 5, 6, and 7. Let's take a look now at 3.3 on getting perspective. Using one colored pencil, draw the images of points P and Q using C as a center dilation and a scale factor of 4 and label it P and P prime, Q prime. So we're going to take our ruler and we're going to draw a ray through the 2 points first of all. And it doesn't really matter how long you draw it. We're going to put points on it in a minute. And we're going to draw one through C and Q as well. And we'll go here and draw it through there. Now I want a scale factor of 4. So the first thing I want to do is measure how far this is going to be. Okay. So again, I can measure it with a ruler if I wanted to. I can see I'm using some centimeters. Doesn't quite get a nice number here. Here it's almost about 1. If I said it was 1, I'm pretty close, right? A little less than 1. Or I could use a piece of tracing paper and just measure that out. Let's pretend it's about 1. And I'm going to go times 4. So 1 times 4 is 4. And we'll go out here to P prime. Again, just a little bit of estimate there. And from C to Q is again about 1. So to go to about 4, we'd go here to Q prime. Now it says using a different color, draw the points PQ using center C dilation and a scale factor of 1/2. Okay, so a scale factor of 1/2. That would mean that if I started at 1, for this point here, 1 times 1/2 is 1/2. So we'd put that right about here. And we would call that P double prime. And over here again, this is 1 again, so about 1/2 is here. And we call that Q double prime there. Okay, and that's what you created in your class today as well. All right, so that was 3.3, and you check that off. And then you went to this next question here, which is a little bit more complicated than normal ones, okay? And you had to make a perspective drawing. To make that perspective drawing, you were given a point or a scale factor there, and you were asked to draw one or label it in such a way that it kind of made sense to you. I'm going to go ahead and make a point just for the sake of what I'm doing here. I'm going to make a point that is, let's go 2 centimeters away, just so I can have one I can work with nice numbers. So I'm 2 centimeters away at this point C. If I was to use a scale factor of, let's go with 1/2, right, times 1/2, that's my scale factor there, then what I would do is I would take my shapes, and I'm saying from this point to that point, I want to dilate it to be half as long, but I still want to stay on that line. So from 2 to 1, cutting it in half, I end up being here at 1, and I can connect my line there for that line. Oops, I should probably get it on the line, or this really won't work at all. Sorry about that. So we're going to go 1 on the line, all the way there. Okay, alright, so I'm starting in the corner. I'm going to go 1 there. For this one, the distance from corner to corner is about 1.5. So 1.5 or 3 halves times a half is going to be 3/4. 3/4 of that. So again, just kind of estimating where I'm at. So this is 1 3/4 is going to be somewhere about here. Okay, so I'm going to put a point there and then connect my lines to there. Over here, this distance from there to there, we're looking at, if I wanted to use like millimeters, I guess I could do that too. I'm at 25, 26, 27, 28 millimeters. So 28 millimeters, and I'm multiplying that by a half, so I end up with 14 millimeters here. So my point would be 10 at 14 right there, and I connect those there. And then here, I am looking at being from the corner to the dot at about 3. So I'm going to go 1.5, which is here to there. So those are my points. So I just basically measured from corner to point, and then did a scale factor for what was missing. At this point now, I can connect my dots, so to speak, and I can make the shape look like that. It's not perfect, but it gets you the idea. There is one of these in the homework that's a little bit like this. It's a little funky, but the idea is showing that I'm just using a point, drawing a line, and then looking at that scale factor. It's the same thing we did before, except now we're just connecting 4 different scale factors, right? All these lines actually all end up connecting here, don't they? If we were to do this, you'd end up with something like that when we're all done. But for now, we're just putting in the rest of the box, and you could shade it in if you wanted to, and that's what it looks like there. Compare some drawings from classmates. It's a little bit tricky, but that's what you got. Okay, then you went to this one here. Are you ready for more? It says here is line segment DE, and its image D prime E prime under a dilation. Use a ruler to find and draw the center of dilation. The center of dilation is going to be where these things come together. So the way to do that would be to take a ruler and draw a line through the points, because those points are going to be on that same line. Alright, so I'm going to go like this for D, and then I'm going to go through E in the same manner. So E is here. We're going to go through E, and we're going to find out where those lines cross, and they cross right here. And where they cross is going to be our point, our center of dilation F, meaning everything is extending out from this point, whatever it might be. Okay, so we have the center of dilation, and now what it wants us to do is find the scale factor of the dilation. Probably the easiest way to do this one, because we're dealing with like non-standard measurements there, would be to take this measurement here, D to F, and maybe make a little hash mark, a little piece of paper, like this on a piece of paper, to see how long that is. It's about that length right there. Okay, then I'm going to take that length and I'm going to copy it up my line and say we got about 1 there, we got about 2 there, and we have about 4 altogether. So my original length was about 4, right? And we're going from 4 and we're dropping that down to 1. So 4 times the scale factor is going to equal my new length of 1. Right? That's the idea. So my scale factor will be everything divided by 4. So my scale factor equals 1/4. That's an idea of how to do that one there. If you use a real ruler measurements, you get crazy numbers. Sometimes it's easier to estimate where you might be. Okay, so my scale factor would be 1/4 right there. Okay, so that's your lesson for today. A quick little summary is that we can use centers of dilation and find out how a point moves along the line, and depending upon if it's growing or reducing, it might be having an increase like a ×3, or the scale factor could be a 1/3. So the key thing here to think about is a dilation with a scale factor less than 1 brings it closer. Okay, a scale factor larger than 1 makes it further away. And that's what you just want to keep in mind if you're estimating things there as well. Okay, let's take a look at tonight's homework. Okay, on tonight's homework we have segment AB measures 3 centimeters. So we have a segment like this that is 3 centimeters long, and we're going to use that for these next questions here. We have point 0 is a center dilation. How long is the image after each dilation with scale factor of 5? So the scale factor of 5 is we take our original, multiply by the scale factor, which is 5, and that tells us our new length, which is 15. Again, our pattern here is we take our original times the scale factor, and that gives us our new length again and again. The scale factor is 3.7. Well, my original is still 3 times the scale factor of 3.7, so my new is going to be 11.1. If my original is 3 and my scale factor is 1/5, I multiply and I end up with 3 over 5. And if my scale factor is s, I have 3 times s, and so I end up with 3s. Okay, just use that little equation right there and plug your values in to see what takes place. Number 2, it says here are points A and B. Plot the points for each dilation described. Okay, it says that C is the image of B, so we're going to copy B using A as a center. So we're going to use that as our center point. Okay, let's first of all draw a nice little line here. If these are going to be connected, then let's draw a line, and we're just going to be able to work on this line for this whole problem. Okay, so we're going to use A as a center, and we're going to go from A to B. Okay, and let's make a little mark here. A to B is from here to here, and at C has a dilation or scale factor of 2. Scale factor of 2 for C. So instead of having one of those, we have 2 of those, and I can put this point right here, and I can label that C. So from there to there is twice the length of there to there. Got it. D, it says, is the image of A using B as a center of dilation, a scale factor of 2. So again, my length is the same, but I'm using B as the center, and I'm going this way times 2, so 1, 2, and I plot my point right there, and I call that D. Check. And then it says E is the image of B using A as the center, and the dilation scale factor of 1/2. Again, I can measure this if I chose to. For right now, your purposes here, I'm just going to eyeball it. 1/2 is about here. So we would say that 1/2 is going to be here, and we'll label that as image E. And then finally we have F is the image that's image of A using B as a center with dilation of 1/2. So again, we're here, that's our center point. We're going 1/2 of what this is, which puts us in the same exact spot, and so we can call it F as well. So this point is both E and point F there. For number 3, I want you to make a perspective drawing and include in your work the center dilation, the shape you dilate, and the scale factor that you use. This question is a little bit tricky once again. So again, what you're looking at is you take a shape, you could draw one yourself, okay, any shape you want. If you make it nice, it's fine. You're going to pick a point somewhere out about here or so, okay? And then to make your shape, what you're going to want to do is pick a scale factor. Let's say I picked a scale factor of 1/3. Then what I'll do is I'll do the distance from here to here, whatever that distance is going to be, here to here on this corner, and I have to think about dividing that into 3 equal parts. So 3 equal parts would be about here and here for my 3 equal parts. Again, this is just an estimate. I could do it with a ruler as well. And so a 1/3 means I'm going to have that point land there, and my first line is going to be right here from there to there. If I look at this point here, from this corner to this corner here, and I'm looking for about 1/3 of that space, 1/3 is going to be 1 and 2, so I'm about here, and so again this line is going to go there. If I look at the bottom one, I'm going from there to the corner, so my distance is here to here. If I take that distance and chop it into thirds, it's going to look something like this. Again, this is just an estimate, and I can then go back from the point and go to where it needs to land, which is here, and then I'm going to connect those vertices there. And then for the last one, I'm going to go here to here, and I have a point, and I have my point, and I make it to be about a third, which is here to here, drop it back in its spot, and I put my point on the third, which is here, and I'm going to connect my line to there, and now I just connect my dots, dot, 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 and I have a shape that looks something like that using a third. You could use a ruler, you can get accurate measurements. Because I'm just doing a little homework help, that's a way of going about it, and that's just an estimate there. It's not perfect. Okay, triangle ABC, it says, is a scaled copy of DEF. AB, okay, let's just draw ABC. So ABC. AB has a measurement of 12. Okay, DEF, which is our scaled copy, and DE has a measurement of 8. This is along its side. Triangle ABC is a scale copy of triangle DEF with what scale factor? So ABC is a copy of DEF. Okay, so our original is here. That's our original times our scale factor is going to give us our new one. So our original was 8. Our scale factor is what we're finding out, and our new value is 12. So we divide both sides by 8, and our scale factor is going to be 12 over 8, or we can reduce that. 4 goes into there 3 times, and 4 goes in there 2 times. So our scale factor is 3 over 2. Okay? Again, original times the scale factor is our new, using the values again. Make sure you read carefully. A real common mistake kids make is they're going to write down 2/3 because they just flip the order of things. So read the order, that ABC is a scaled copy of that one. So that's my original right there. Let's look at B. It says DEF is a scaled copy of triangle ABC with what scale factor? So this case, the same idea as before, because DEF is the copy, we do the original, again the original times the scale factor equals the new, and the original being ABC, the original value of ABC's length was 12, times the scale factor equals the new, divide both sides by 12, and our scale factor in this case is going to be 2 over 3, right? It's the reciprocal of before because of just the order of things. So be careful when you read that. Number 5. Number 5, it says find the missing angle measurements. So here we go. Cross is a vertical angle, so angle B is 102 degrees. These two angles combined is going to be supplementary, so we're going to have 180 minus 102, which is going to equal 78 degrees. Because these are vertical angles, this would also be 78 degrees, and there we go. So we have 78, 102, and 78. And finally our last one here, we want to show the two triangles are congruent, and we want to find the side lengths there. To show that they're congruent, what we're going to want to do is we're going to reflect this over the y-axis, okay, and then we're going to want to take that shape and we're going to translate it down so that point A matches point D. The idea being, I take this shape right here, there it is there, I recognize that it's not going to be the same as that one without a reflection. So when I reflect it, now it's going to line up. I can reflect it over the line, and then I can translate it down so that point A lands on top of point D. That's the idea. Now because it's congruent, the side length of DEF is going to match. So if this one was a 5, and you can draw this out here, if this is a 5, a 3, and a 3.2, it might help you to flip it and read backwards a little bit to say that this would be 5, this would be 3, and this is 3.2. So it's congruent, our parts are gonna go there. Don't be thinking scale factor stuff, we're just moving things. In terms of the angle measurements, which is the last question here, again, your angle measurements always stay the same. So the large one here is gonna be 108.4. The one down the corner is going to be 36.9, and the one up top is going to be 34.7 degrees. Angle measurements are going to stay the same. In this case, our lengths stay the same because all we did was we just did a translation. There wasn't any scaling. Okay, Hope that helps your homework. Good job, and we'll see you next time.